This is AP1401 or number 4 as the assignment, and it's the second one for this week. So here's why I put this one on here. You notice the table that has the mass of the Ki tablet, potassium iodide tablet, mass of thoroughly dried filter paper, blah, 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 blah. This is one of those problems that simulates what actually happened in the laboratory, which is kind of a good idea for, obviously, a chemistry exam. So I just wanted to point out what it says, though. It says, for the directions, it says questions 1 to 3. This is like for your information as far as going through the process of taking the AP chemistry exam. You would have, like, the most updated version has has 3 long free response questions that have multiple parts. You should do about 20 minutes each on each one of these, okay, and they're worth 10 points each. The last 4 to 7 questions are shorter, take less time, and are worth less points, 4 points. Just to give you an idea. So this portion of the test, the second portion of the test is 90 minutes long, and you have to answer 7 questions, 7 complete questions in that time, as opposed to 90 minutes long for the multiple choice questions. There are 60 multiple choice questions. You get about 1.5 minutes for each question. All right, I just wanted to give you some basic idea as to what the AP Chem exam looks like. So let's take a look at this problem now. A student is given the task of determining the iodide content of tablets that contain potassium iodide and an inner water-soluble sugar as a filler. The tablet is dissolved in 50 milliliters of distilled water, and an excess of 0.2 molar lead 2 nitrate solution is added to the solution. Okay, so an excess. So this is not a limiting reactant problem, which is good. A yellow precipitate forms, which is then filtered, washed, and dried. The data from the experiment are shown in the tablet above. So for the chemical reaction that occurs when the precipitate forms, write the balanced equation, net ionic equation for this reaction. Write the balanced net ionic equation for this reaction, and then explain why the reaction is best represented by a net ionic equation. Excellent, no problem, we can do that. So let's take a quick look at what we have. It says for the chemical reaction that occurs when the precipitate forms, write the balanced equation. So what do I have? I have a tablet that has Ki. Ki is, this is actually, they dissolve it in water. Yeah, they dissolve in water, and that's how it reacts. So I should put AQ for this. And then lead 2, come on, this thing is, I don't need the +2 because I'm going to write the full thing down here. There we go, like that, over here on this side. Now, when we get this far, here are the 2 reactants. When we get this far, we have to decide what kind of reaction is this. Is this a synthesis reaction? Is this a a decomposition, a single displacement, or a double displacement reaction? Okay, if you said double displacement, you would be correct because there are 2 compounds, compound plus a compound. So on the left-hand side, we have AB plus CD. Okay, on the right-hand side, if you guys remember from honors chemistry, we put A and D together. So A is K with a +1. You have to go back to the charges. NO3 is nitrate, and that has a -1, like that. And then I go on to the next one, and it's C and B. Now, C is still positive, so the lead is still positive with a +2. And then it's the I, that's a -1. Now, when I go to make these compounds, the formulas for them, the +1 and the -1 cancel out, but I do have to crisscross the PBI to give us PBI2, like that, and then we can get rid of the charges. So this is the molecular equation, and so far I want A, D, C, B. Okay, that's from all the stuff that we learned from last year with the honors chem. If this is a really stretching it as a review for you, then I apologize, but here's what it looks like. This is the molecular equation, not the net ionic equation. So the net ionic equation is when we turn all of this. Well, first of all, the first thing I need to do is figure out which one of the products forces the equation to happen. Like which one of the products changes its state or looks different than all of the aqueous solutions that we have here. So we have aqueous for Ki, we have aqueous for PbNO3 too. Now we take a look This is, and I attach this to the homework, I attach this to the assignment. This is the solubility chart. So the solubility chart here, I'm going to, my first compound that I produced is potassium. And if you take a look at potassium, they are all AQs all the way across, which means potassium does not form a solid that does not dissolve in water. Okay, so let's take a look at lead then, because lead is the next one. So potassium nitrate is this one right here. Where are we at here? Nitrate, potassium and nitrate is right here, and that's AQ. But if we go to lead iodide says P. We're looking for a P or an S, and we have a P, which means partially soluble, which means that it comes out in the solution. So I go back here. This one is aqueous. This one is going to be a solid. I don't put a P here, I just put the S for the solid. So a good portion of the PbI2 is a solid. Okay, so that's what, now that is the driving force for this reaction. The fact that it changes, the PbI2 comes out as a solid, which means the rest of the stuff is just kind of floating around. So what is the rest of the stuff? So let's go through. What I have to do is, let's balance the equation first. Notice that I have, if I look here, I have 1K and 1K, so that's balanced. I have 1 I, but over here I have 2 iodines. So I put a 2 in front of the whole compound. Now I have 2 Ks, and I only have 1 K on the right-hand side, so I put a 2 in front of that, and that gives me 2 nitrates. 2 Ks and 2 nitrates. Over here I already have 2, so that also works. Okay, I know this is dragging on a little bit. I'm going to pick it up. I go through and 2K with a plus, 2I with a minus. All I'm doing now is writing out everything that's aqueous. I'm just doing all of the charges. So Pb with a plus 2, and then I have 2 NO3s with a minus 1. And then I go to the next side. 2 Ks with a plus 2 NO3s with a minus 1, and then plus. Now this is not an AQ, so this stays exactly the same, like that, as the solid. Okay? Now I go through here to get the equation, to get the net ionic equation, I get rid of all the extra ions that do not change from one side to the other. And it looks like these are the ones that don't change. So that means I have 2I minus plus a Pb plus 2 yields, and then PbI2. And that's a solid. Okay, that's it for letter A. That was a lot of information.